Hello viewers, welcome to SciTech and so thank you all for supporting me to do and motivating me to do videos on microfluidic channel designs. And thank you to the people who are sharing me their research articles to do videos on. And today, whatever we are going to do is also shared by one of the researcher. And I also request others to please share the research articles. It might give an email ID if you face difficulty, and I can help with that. And today, moving ahead, today's video is on glioblastoma on chip models. So this is a research article actually, and I'm doing this video just for educational purpose, not for any promotional. And I thank all the authors of this uh, article. So moving ahead. So today let's plan or let's aim to design this microfluidic channel. If you see, the idea of this microfluidic channel is to create a 3D environment of monitoring the invasive nature of glioma cells. So this is where the cell culture media can pass in the blue region. And this is the collagen filled microfluidic channel where the cells can be trapped into this grooves. So this is what the aim of the author who did this work, which is very interesting. And today, let's just try to do this designing part. So moving ahead, just open in the SolidWorks and create the new assembly file. Like this process, by now everyone should have been familiar because this is what we were doing in the last videos also. So insert the new part, edit the part. So basically, if you want to change the background, you can change it from here. I like to be plain white, so it will be white. And now select the plane, draw a rectangle. So this is for base, to draw just a base. So let's keep it as 20 mm cross 40 mm. And extrude. So extrusion height or 3D height can be 12. This is more than sufficient actually. And select this place, click on sketch. So now this is where we start the designing. So if you see in this, the main tricky area lies is this collagen gel area, this grooves. So most of the researchers face difficulty in drawing this uh, region symmetrically, and then it should be so precise that cells should come and capture in that. It is not the cell culture media should enter into the gel. So the dimensions are 500 microns of this channels, which are the cell culture media channels, and 600 microns for this. And it has a length of 2 mm. So I just take this, I don't use these dimensions at all because to just maintain the integrity, I'll do the new dimensions. So let's aim to do initially with the middle or the groove area. So initially I just drawn the random line, and now to the random line, the center of the random line and the center of the origin, I'm just giving the collinear relation so that now the line is in middle. Right. And after that, let's give the dimensions of this line somewhere around 25 mm. Observe here, this is 25 mm. And then from this design, if you see, this is basically the region. So there's a microfluidic channel inlet, and this is the region which is like a square. So let's aim to draw a square initially. We can have the square dimensions here. So let's keep it at 10 mm. And this, so it was 600 microns, but I'm keeping it at 1 mm. So it's 1000 microns. So these are all like arbitrary dimensions, and depending on the applications, you can change. But, okay. So if you see, the grooves are somewhere like some. So let's draw initial groove design here. This point in the center of this line is connecting to this line. Right. And now let's give the dimensions between these two. Right. This is the initial channel. This is what we are creating. And now on the top of this sketch, we have to create the channels for the cell culture media to enter and exit. So it is very simple now. So let's draw a line over here. Okay. So like previous, let's do a collinear operation over here. Give the channel dimensions as. So it was 10 mm channel, so it can be 15, or let's reduce it to 12. This has to be in connection to this, or it can be more. Right. Let's do in a two ways. Okay. So this will result in a thin when you do the extrusion cut, this will result in a formation of thin sheets. So that won't that operation won't be accepted. If you are connecting this line and the end of this sketch, and then you do collinear, and if you start sketching, so it will lead into a error. So you cannot do extrude cut after your complete designing. So before that, what I'm doing, so let's do one thing. Initially, let's draw a center line. And we know that the design was 1 mm of 1 mm groove channel. So now let's do one thing. 0.49 I am giving. So when you extrude it, sorry, it should be 0.99. Okay, so it means that there is a 0.1 mm gap. Sorry, 0.01 mm gap. Okay, so this may be during the operation you will understand. And the next, it can be a line over here. It's a simple line. Let's keep again this is 135 degrees. So you want to have a shape. This can be split. Choose the fillet over here. Fillet time. So you might get a doubt that from the research article, if you see the design looks something like this. Okay, it's all connected, it looks. And when I was going through also, I felt the same thing because the printed design is something like this. It is shown, but this is after filling with hydrogen. So to just confirm, I went to the parent journal article, not the review article. From the review article, I took the citation and went to this parent article. So this is the article by Yuta Chonan, like inducing or monitoring the three-dimensional invasion of heterogeneous glioma cells in the 3D microfluidic platform. So when I went through this, I found that the design is not that as shown in the review article, but it is something like this, whatever we have designed. So you'll have the pillars standing, and in between the grooves, the cells will go and set. So just to confirm, so I'll show you some microscopic images. So if you see there's images, so this is how the pillars are standing, and this is where the cells are incoming into the 3D microfluidic channels. Right, I hope this is clear. And the next part in our design comes is just to close this microfluidic chip with the top cover. So to do that, just exit the sketch, insert new part, edit this, select the face, extrude it to 0.5 mm. This is how the inlets can be created. And again on the top of it, you just create the center rectangle. This can be, I prefer it to be 3 mm and 3 mm. So it depends on the individual set. Can be equal and concentric. You'll draw somewhere. Select this one, equal and concentric. Okay. Now same way, just draw a center line. Mirror entities. Copy about this line. And I prefer extruding 3 mm again. So this is how the final microfluidic chip looks like. And once you do transparency, so you can see the inner view, internal cell invasive model for glioblastoma cell. So this is a 3D model of that. So this how it looks. Okay, and then if you want to print it, just save into the STL files, and then I think in one of video we showed the helical structure, how to print the 3D helical structure. The same way you can save into STL files and just continue printing and doing your microfluidic stuff. So thank you so much for watching this video, and let me know if any difficulty if you're facing in designing microfluidic chips. Share me the articles, and depending on the possibility, and I'll be doing it and again sharing it back to the microfluidic community. Thank you all for watching this video.